Okay, this will be a very short video to summarize the main points of the exponential and logarithm functions chapter. So we start by the basic fundamentals first. So in this chapter, in log and exponential, there are two main forms that we look at. First thing is called index form. So for example, if I have a power x equals to b, this is an example of an index form. So for example, 3 power x equals to 2. This is an example of an index form. Whereas I also have a logarithmic form, which is, for example, I have log base a b equals to x. So to give you an example, let's say, right, we can look at very clear examples. Log base 9 equals to 2. This is the logarithmic form. 3 square equals to 9. This is the index form. So what log does is that it helps us tell the power that we need to put this base to in order to get this number over here. So for example, let's say this log, right, this is log base 2 and 8. So what this means is that the base here, which is 2, I need to have a power of 3 in order to get 8, which is what I see over here. Okay, another example, let's say log base 10, 10 equals to 1, meaning that my base here, 10, needs to be to the power of 1 in order to get 10. And if let's say log base 7, 1 equals to 0, the reason why is because base 7 power 0 is equal to 1. Okay, so basically that's the main gist of how we look at logarithmic functions. You need to be able to understand the relationship of how the base relates to this number over here, which is essentially the base power whatever number over here will give us this number within this log function here. Okay, so in this chapter as well, we also learned the basic laws of logarithm. If I have log base axy, I can split this into log base ax plus log base ay. And if this works both ways, I can either split it apart or join two log functions with the same base back into x times y. Okay, and if it's a minus sign, I can combine two log functions with the same base. Emphasize that it must have the same base. If I have log base ax minus log base ay, I can combine this into log base a x divided by y. Okay? Then the third law of logarithm, which you have learned before, which would be, let's say I have a log base ax and I have a power here. By the laws of logarithm, we can actually shift this power down. So this will be equals to n times log base a x. Okay? Then any logarithm function, whatever base this number is, if to get 1, it will always be equals to 0, meaning that a power 0 is always equal to 1, whichever a is. Okay, and log base a power 1 is equal to a itself. Then the last one but very important formula is the change of base formula. Let's say I want to change base from base a into base b. So I'll write log base ax is simply equals to the new base log base b x over log base b a. This is how we obtain the new base through the change of base formula. Okay, so I'll illustrate what we can do with these laws using very basic fundamental practice questions. So let's say, right, we always use log when I have unknown powers. So let's say, right, in example 1 over here, I have 3 power x equals to 2. Solve for x. What can I do? I can use log to actually bring down the power. So my first step to solving this is that I'll take log on both sides. This will be equals to log 3 power x equals to log 2. I take log on both sides. Then by the laws of logarithm, I can actually bring the power x down. This will be equals to x log 3 equals to log 2. And therefore, I can make x the subject. X will be simply equals to log 2 divided by log 3. Then you can express your answer in 3SF, whichever, when you key this out into your calculator. Okay, and also to recall, if I write log, it is a short form for log base 10. Okay, and also logarithm is also useful because not just power x. If let's say in this case over here I have x power plus 1, I can do the same thing. I can use log to bring down the power as well. I take log on both sides. This will be let's say log base 10 x power plus 1 equals to log base 10 3. Then after that, by the laws of logarithm, I can bring this power down. this will be x plus 1 times log 10 equals to log 3. Then from here, x plus 1 is simply equals to log 3 over log 10. And therefore, x is equal to log 3 over log 10 minus 1. Then you can key this value into your calculator into 3SF. Okay, so this is example 1 of how to solve equations that's with unknown powers. So over here, when we have unknown powers, we can easily use logarithm to bring the power down. Second example, this is from your the YTSS EOY 2023 Sec 3 AMF paper. So find the exact solution of this equation over here. How to solve logarithmic equation. So the first thing that I must always do is that to make it easier to solve, I want to make all the base the same. So currently I have a log function with base 2, and here I have a log base 4. So what my first step, intuitively, what I can do is to actually make all of them have the same base. So over here, I can rewrite this again, log base 2, 3 plus log base 2 x over 3. And in order to change this using the change of base formula, I will get, to make them log base 2, this will be log base 2, 3 over log base 2, 4 equals to 1. Okay. Then from here, I can see that using my product law, since these two log functions have the same base 2, I can combine 3 and x over 3 together by multiplying them. So this is simply log base 2, 3 times x over 3. Then for this log function here, this is log base 2, 4, which will give me log base 2, 3 over 2 equals to 1. Okay. Then from here, this I will get log base 2 x minus half log base 2, 3 equals to 1. And from here, you notice that I have log functions with the same base, but I cannot combine them yet because I have this half that is blocking me. So what I can do is that I shift this half into this log function here. So this will be log base 2x minus log base 2, 3 power half equals to 1. And actually, if you realize 3 power half is simply equals to log base 2 root 3 equals to 1. And therefore, now that same base, and this is just a minus in between these two log functions, I can combine them together. I'll get log base 2 x over root 3 equals to 1. So then from here, how do we solve this log equation? We go back to what the fundamental meaning of what a logarithmic function means. This means that base 2 power 1 equals to this. Okay, so to write this clearly, the log base function, the index form would be the base power 1 is equal to x over root 3. So very simply, therefore, to solve for x, I multiply root 3 to both sides. This will be simply 2 power 1 is 2, so this will be 2 root 3. Okay? Yeah, so this is a very basic example of how to apply the laws of logarithm into solving logarithmic equations. And please go and try out other methods of solving as well, including substitution. These are all very important techniques that we'll use in solving logarithmic equation. So this will cover a brief summary of what the chapter of logarithm and exponential function is. Exponential functions and logarithm, if you can grasp the concept of logarithmic functions, exponential functions like ln, they have the same properties. So you should be able to apply them as well for this chapter. Yep, so that's the end of this summary for this chapter.